to start, we click Fluid, Flow Fluent, and we're going to drag that over right there. And now we're going to click on Geometry, edit it to make it 2D. And then we're going to go back to Geometry, edit, and then do Design Modeler. Takes a little bit to load. Okay, so this is a new Design Modeler. So now we're going to switch to the XY plane, where we're going to draw a sketch. So we're going to click rectangle right here, drag from the origin, and now we got to change our dimensions. So we're going to click on the left edge, drag it out, and the top edge, and drag that out. And now we're going to change our height to 0.02 meters. Sorry, not 0.02, 0.002 meters. And then we're going to change the length to 0.3 meters. Now that we've done that, we're going to go up and zoom in since we made it super small. I made it small, so later on you'll see why, but it makes it easier to read the whole rectangle without having to zoom over too much. So now that we did that, we're going to center it, and then we're going to go up to the Concept tab and click on Surfaces from Sketches. And now that we click Surfaces from Sketches, we're going to go to our sketch, and we're going to click Apply under that, so it does that. And then once we apply it, we're going to generate it so it fixes for the whole rectangle, and it'll make it gray on the inside just like that. Now we can go back to our workbench. And once we're in our workbench, now we're going to do the meshing phase. So we're going to click on Mesh, and that should pull up a separate tab. We're going to be working in the XY plane again. We're going to click on Mesh, Insert, Method. We're going to click on the inside of the rectangle and apply that. Takes a little bit to load. Okay, now we apply and then generate. Now we're going to go back to Mesh, click on that, Insert, and then do Edge Sizing. Sorry, not Edge Sizing, Sizing. We're going to be clicking on the edges. So we're going to click on the Edges tab, click on both the left, hold Control, click on the right. So now that we have the two edges selected, we're going to go over and click Apply. And that has the two edges. And now we're going to change it. So number of divisions. And then I believe I did 100 divisions. Right there. Then click Capture and click No. And that allows us to change our behavior, which we're going to make that a hard behavior. And then once we click a hard behavior, we're going to go up and we're going to generate that. It takes a little bit for it to mesh. Okay, so it was quick because it was only 100 divisions. Now we're going to do from the top to the bottom. So we're going to go to Insert, Sizing. And now we're going to be doing the top edge and the bottom edge. So click on the top, the bottom. Once they're highlighted green, they can go over to Geometry and click Apply. And then we're doing the same thing we did with the left and right side. We're going to change the number of divisions. And then for this one, I made the number of divisions 1,500. And then also change that so it says no to make it a hard behavior, just like we did with the other edges. Okay. Once that's done, we're just going to go up, click Generate. So now that we generated that, you can see the mesh. We zoom in, and it's going to be the little divisions that we did. 100 times 1,500, so it should be 15,000 divisions. Now we're going to go to face meshing. And now that we face meshed, we have to use the whole sketch. So we're going to click on the rectangle right here, then click Apply. And then once you do that, you can generate it, and that will be your full mesh. Now that we've meshed everything, we're going to click on Mesh. Okay, And now we're going to go to the edge selection, which we already have labeled or clicked on up there. We have to click it, go to the left, and then we click on the left edge, and then you just go down to the name selector. And we're going to make the left edge called inlet, which is where the velocity is going to go in. And now we're going to do the right edge. And then as a shortcut, you could just click the N, but I just kind of clicked that so you can see the process. We're going to call the right edge outlet. Click on the top edge, and that'll be our upper wall. Okay, that's okay. Now we're going to click on the bottom edge, and this will be our lower wall. Now we just generate that. Basically, generate is just going to update everything. And now we can go back to our workbench. So at our workbench, now we're going to go to the setup tab, which we're going to be doing, changing the density and the speed and all that stuff. So right here, we click double precision and then start. This one took a little bit longer to load up. Because there's a full model, it takes a little bit longer to load up. So at the bottom there, you can see it's loading. And a little pop-up came up. So it says, okay, don't show this message again. Okay. Okay, now we go to the models. And this is where we're going to change it to laminar. So click on laminar model. Okay. And now we're going to go to close that and go to materials, fluid. We're using air. And we're going to change the constants under there. So that's everything. Change the constants to 1.184. I found that best with the Reynolds number. And I'll have the calculations in my thing, but I believe I changed this to 1.849. Okay, so we click that, double check it, save, and close. Now we're going to go down to our boundary conditions. This is where we're going to change the velocity and everything of the inlet and the bottom wall, or top wall, sorry. So the inlet was 5 meters per second for the velocity on the prompts. Click apply. Okay, we applied, so now we can close. And then just to make sure it's safe, we're gonna click back on inlet because sometimes it changes. Okay, it's the same. Now we're gonna go to our upper wall. And we're gonna edit. And we're gonna change that to, it was 3 meters per second. And then leave everything else the same. So apply. We can just close. And then down below, oh wait, before we do that, let's check this, make sure it's stationary. So that's the outlet, so that's not gonna be anything. But our lower wall should be stationary if we click on it. Nope, it's stationary, so we can apply and close. Now we're gonna close out of that, close everything else, and go down to our reference values. So this is everything before, this is just baseline for the air, which was just automatically input. But now we're gonna go up to, actually, no, that's different. Okay, we're gonna go up to compute from, click on inlet, as that's what we set it as. And then that should be the same numbers we put in earlier, the 1.184 and the 1.849 times 10 to the negative 5. Okay, now we're gonna initialize. Just click on initialize, and that's gonna have all the numbers at the bottom of the screen. Now we're gonna run our calculation. So here we did 100 iterations. Then just click calculate. Then it's running everything at the bottom, and it's going to create a chart, as you'll see. Okay, so there's a chart. Shows everything has the same shape. The green line for the continuity, the purple line for the x velocity, and then the y velocity is our red line. Looks about right. Our calculation's complete. Okay. Everything is looking right. So now we're going to do our vectors. So you click on go to results, vector, and just make sure every setting is correct. 3D arrows we want. Vectors of velocity, correct. The scale. Save the changes. Then it doesn't appear for a bit, it's loading. I'll just compute it. And we should close it, it'll pop up. Okay, we gotta zoom in. And once we zoom in, you'll be able to see it. I don't have a mouse, so it's kind of weird to zoom in and out. So we're zooming in. Now we're gonna go to the left side, and that's gonna show how at the beginning the velocity goes like that, and then it just goes inward with the boundary layers. Since the velocity at the top wall is moving, there's gonna be more velocity at the top than there is at the bottom. As you see, it's slower at the bottom since it's stationary. I go all the way to the right side, and as you go, it gets slower towards the bottom, but it speeds up in the middle. Okay, if we zoom in, super right in the middle, that'll be later. You'll see our max velocity. When we go back to our workbench, click on results. Go to the XY plane. Now we're going to set our midpoint and our endpoint. So we're going to make a line. That's going to be our midpoint. And for the points, we use 0.15. That's the middle, since we made our length 0.3 meters. Then go to the height. We made our 0.002. Then with 100 samples, apply. I gotta fix that. The yellow line went to the top. Oh, 0.002. There we go. Now it's the midpoint. So now we can go back to, we're going to do the endpoint now, line, endpoint. And so it's not messed up at the end. We're not going to do exactly at 0.3. We're going to do 0.299 for point 1 and point 2. The top, it's the height, 0.002. Bottom of 0, we're going to change it to 50 samples and click apply. And it's showing the endpoint. And then now for later, so it's easier, we're going to click point. We're going to type max velocity. You'll see later why we made this point. It makes it a lot easier at the end. And we're going to make it a variable maximum. Make it for the whole rectangle, so it's the symmetry 1. And then velocity u, so it's the velocity in the x direction. Click apply. And that little crosshair shows where the point is at for our max velocity. So now we're going to do a contour. So we're going to do our velocity contour first. Click OK. And then we're going to make the location symmetry 1, so it's the whole rectangle. We're going to make our variable velocity u. And number of contours, I did 100, just so you can see everything and it's smoother, because the less contours, the less smooth it's going to show. And that's our velocity contour. I was having trouble zooming in, so it's just rotating. Okay. Now I'm going to move over to the left so we can see the inlet. So at the inlet, it's a little slow towards the beginning, but it gradually gets faster, as you see. That's what we did our max velocity point, is max velocity was at the end. So that was our inlet. Then as you go towards the end, you'll see on the left, matching the legend, that it's super dark at the end, a dark red, which is where our max velocity is at, which we'll calculate later what the exact number is. Okay, now we're going to do our pressure contour. So symmetry 1, pressure, make it also 100 contours. Click apply. Then we're going to uncheck the velocity contour so you can see the pressure. Then we're going to zoom in. So at the inlet beginning, where at the bottom where it's stationary, zoom over. It's darkest right there because that's where the pressure is the highest. Stationary, bottom of the wall where it's stationary, matching with the inlet where the velocity is coming in. And as we get towards the end, the pressure is very small. There's little to none pressure at the end, which makes sense because where the max velocity is, there's less pressure where there's max velocity. Okay, and that's all right. Pressure contour. And that's the full pressure contour zoomed out. So now we can check both. Actually, I'll uncheck both of them, because now we're going to create a chart. This will be our velocity profile chart. So now we got to edit it. We're going to call it velocity profile. No caption. Our data series is going to be the two lines we made. Midpoint and endpoint. Okay, x-axis, we're going to change velocity u. That's what's going to show in our chart so we can see where the velocity is, how it's reacting at the midpoint versus the endpoint. Y-axis is just going to be our height, y. And then we'll make the midpoint, no, I think I'll leave it. Actually, we'll change it. We're going to make our midpoint a dashed line. Click apply. And it's super hard to see, but at the endpoint is just outside of it. They have similar velocities, but it's just outside of it. So from the midpoint to the endpoint, it's very hard to see, but the endpoint has a higher velocity, as we saw from when we made the point. So just showing I'm clicking on the endpoint and the midpoint, separating them so you can see that it's zoomed out. They look pretty much on top of each other, but the endpoint just has a higher velocity by a very small amount. Okay, so we go back. We're going to go to tools. We're going to calculate our max velocity. This is why we made the point earlier. So we go to our function calculator. Click on function. We're going to go to probe, as that's used as a point. We're going to use our location as max velocity. And change the variable to velocity u. And click apply. And the value we got for the velocity is 6.84295. That's our max velocity at the endpoint. Or our max velocity of the rectangle, but it's close to the endpoint. So now we're going to do the height for where that's at. And when we calculate that, it's at 0.00114 meters high.